Hi guys, welcome to Phoebe Explains. The brain teaser for today is that how many routes can the bee take to reach the flower? Given that the bee can only move upward or leftward, the bee can never move rightward or downward. How many ways are there? For example, the bee can move 2 steps upward, then 3 steps leftward, or the bee can move 1 step leftward, 2 steps upward, and 2 steps leftward. How many ways are there in total? If we extend this problem a little bit, instead of being placed on a 2 times 3 grid, this time the bee is placed on a 4 times 4 grid. How many ways are there? Please pause the video a little bit to think of the solution for these problems. Well, as you already realized that if we do it manually, like listing out all the possible solutions, it will make this problem a little bit complicated and it will take a lot of time to count all the possible solutions, especially when the grid is larger, like 100 times a 110 grid. So instead of solving problems by manually listing out all the possible solutions, no matter which route we pick, the bee always moves 2 steps upward and 3 steps leftward. So instead of solving this problem graphically, we can actually solve this problem as a combination permutation problem. Well, if you haven't learned arrangements or permutation, let me quickly explain this. If all these 5 arrows are distinct, then this problem is not difficult to solve. As for 5 position, for the first one, there are 5 options as we can pick any of these here. And for the second one, there are 4 options as there's already one picked in the first position. And in the third position, there are 3 options. In the fourth position, there are 2 options. In the last position, there is just 1 option left. So in total, there are 5 times 4 times 3 times 2 times 1 different arrangements, right? So we call these 5 factorial. However, in today's situation, these 2 red arrows are the same and these 3 left arrows are the same. How can we solve this problem? Well, if we list out all possible solutions, these are all the possible arrangements for upward arrows. If we look at the first arrangement, we can see as these 2 arrows are the same and these 3 arrows are the same. There are just 1 possible arrangement for the first case. However, if these 2 arrows are different, we'll have 1 multiplied by 2 arrangements for these positions. As for the first position, there are 2 options. For the second one, there is 1 option only, so it's multiplied by 2 factorial. And at the same time, if these 3 left arrows are the different, we'll multiply it by 3 factorial then. Because for the first position, we'll have 3 options. For the second position, 2 options. And for the last position, 1 option. So if we assume there are y arrangements for these 5 arrows, we can get the formula that y multiplied by 2 factorial multiplied by 3 factorial is equal to 5 factorial. So y is equal to 5 factorial divided by 2 factorial times 3 factorial. Now let's have a look at this case. In this 4 times 4 grid, we can see that there are 4 up arrows and 4 left arrows. So in total, there are 8 arrows. So if all these arrows are distinct, we can have 8 factorial of different arrangements. However, as 4 of these arrows are the same, we'll divide it by 4 factorial, and 4 of these arrows are the same. We'll further divide it by 4 factorial. Now we can generalize this problem in n times n grid. Are n up arrows and n left arrows. After knowing the method, we can find this number of routes quite easily. So in total, we will have n plus n steps. So if all these steps are distinct, there will be n plus n factorial cases. However, as these n up arrows are the same, we'll divide it by n factorial and at the same time, as these left arrows are the same, we'll further divide it by n factorial. So this is the generalized case for the number of routes the bee can take to reach the flower. So this is the end of today's brain teaser. Hope you enjoyed today's video. See you in the next one. Bye!